Hi, welcome back to Geometry. This is Chapter 4, Congruent Triangles. This is Section 4.5, Isosceles and Equilateral Triangles. You might remember from earlier that an isosceles triangle is a triangle that has two congruent sides, and an equilateral triangle is a triangle that have all three sides are congruent. So our objectives in this lesson are to use and apply properties of isosceles and equilateral triangles. It's essential that you understand that the angles and sides of isosceles and equilateral triangles have special relationships. Anytime along the way, you can pause the notes to fill in your template. An isosceles triangle, so you should draw this picture in your note template. An isosceles triangle, it has two congruent sides that are called the legs. So these are the legs. The other side is called the base. And the two angles at the base of the triangle are called the base angles. So the two angles that are along the base side are the base angles. And they just happen to be across from the legs. And then this other angle, the one that's at the top where the two legs meet, that's called the vertex angle. So you would want to draw this isosceles triangle and label its parts. The two congruent sides are called the legs, the non-congruent side is called the base. The angles that are across from the legs that lie on the base are called the base angles. And then the angle that's formed by the two legs is called the vertex angle. Theorem 4.3, the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So, if segment AB is congruent to segment AC, then that means that these angles, B and C, are congruent. The angles that are across from the congruent legs are congruent. So, if it's an isosceles triangle, because you know the legs are congruent, then you know the base angles are congruent. The angles that are across from the congruent legs. The converse, remember converse means the backwards. It's when you make the hypothesis the conclusion the hypothesis. If two angles of a triangle are congruent, so in this case, if angle B is congruent to angle C, then you know the sides opposite them are congruent. That means you know that segment AB is congruent to segment AC. So if you know two angles of a triangle are congruent, then you know the sides opposite them are congruent, and you know that this is an isosceles triangle. Let's prove the isosceles triangle theorem based on what we already know. If you are given that WX is congruent to XY, and you are also given that segment XZ bisects this angle, WXY. Well, bisects means it cuts it into two equal angles. And then we also know that XZ is congruent to itself, XC. Then you can prove that these two triangles are congruent using side, angle, side. So if we can prove they are congruent using side, angle, side, then we could prove that their corresponding parts are congruent. Using corresponding parts of congruent triangles are congruent. So let's write the proof. Segment WX is congruent to segment XY. We said we knew that because it was given to us here. Segment XZ bisects angle WXY. We said we knew that because it was given to us. And therefore we know that angle WXZ is congruent to angle YXC by definition of the word bisects. Next we said we knew that XZ was congruent to itself using the reflexive property. So finally we said we have enough information now to prove that these two triangles are congruent using side, angle, side. And if you can prove the two triangles are congruent, then you can prove that their corresponding parts are congruent. angle W is congruent to angle Y because they're corresponding parts of these two congruent triangles that we've proven using side, angle, side, side, angle, side. We knew side WX was congruent to side XY. We knew that segment XZ bisected angle WXY. That meant that these two angles were congruent. And then we know this side XZ is congruent to itself by reflexive property. Side, angle, side. So these two triangles are congruent, and therefore using corresponding parts of congruent triangles are congruent, we can prove that angle W is congruent to angle Y. If you take a look at this picture, this is an isosceles triangle. If we knew the sides were congruent, well, we just proved the theorem. If the sides are congruent, then the base angles are congruent. We didn't need to go through all these other steps. We knew step one, that the legs were congruent, and therefore, using the isosceles triangle theorem, we know the base angles would be congruent. We could prove this every time using the same proof, so we don't need to. Once you've proven a theorem, you can use it. Theorem 4.5, if a line bisects, remember bisects means to cut in half, the vertex angle of an isosceles triangle, then the line is the perpendicular bisector of the base. So, if segment AB is congruent to segment AC and angle BAD is congruent to angle CAD, then you know AD is the perpendicular bisector of BC, and therefore you know that this is a right angle and that these two sides are congruent. Then you could prove those two triangles are congruent using hypotenuse leg. Corollary is something you can easily prove. So the corollary to the Base Angles Theorem or the Isosceles Triangle Theorem is that if a triangle is equilateral, then it's equiangular. So this is just like that isosceles, but if the sides are all congruent, then the angles across from them are congruent. And then the converse of that would be if the angles are congruent, then the sides across from them are congruent. So the rule you need to remember is that if it's equilateral, it's equiangular, and if it's equiangular, it's equilateral, which I think most of you already knew. We've talked about that, how if the sides are congruent, then that means each of these angles is going to be 60 degrees, because 180 divided by 3 is always going to be 60. All equilateral triangles are 60, 60, 60, and they're also called equiangular. Equiangular means all the angles are equal. So let's use equilateral and isosceles triangles to find the values here of x and y. We are given this larger triangle, triangle ABC, and it's marked that it's equilateral. So what do you know about all of the angles? Angle A, angle B, and angle C are all 60 degrees. So x would be 60 because 180 divided by 3 is 60. Then we have this other triangle here, BCD. Well, if we're given that this small angle is 30, and we knew the whole thing was 60, that means this piece is 30. And if you take a look at this triangle, without all this other writing on it, you'll see that it is an isosceles. If the legs are congruent, then the base angles are congruent. So if this is 30, this angle here, then y is 30. So we got the 60 because we knew the bigger triangle ABC. If that was x, then these are all 60, 60, 60. Because it's equilateral, it's equiangular. We got the value of y because of this smaller triangle. we knew that these sides were congruent, and if this angle was 30, then this base angle is 30, because the base angles are congruent. Let's try another one. Find the values of x and y. In this case, we just have an x. So these congruent symbols mark that this is an equilateral triangle. If it's equilateral, then you know it is equiangular. Therefore, all of these angles are 60, 60, 60. So 3x is equal to 60. So the value of x, well, you would undo times 3 by by dividing by 3. So x would be 20. Let's take a look at this next example. These congruent marks represent that this is an isosceles triangle, and therefore those are the legs. The two congruent sides of an isosceles triangle are called the legs. That means they're equal to each other. So 6x minus 4 is equal to 20. So the inverse of minus 4 would be to add 4. So 6x is equal to 24. The inverse of times 6 would be to divide by 6. So x is equal to 4. 6 times 4 is 24, minus 4 is 20. So both of these sides are 20. Let's look at the last example. Well, this tiny little triangle up here at the top is showing that that's right, an equilateral triangle. So that means that this is 3 and this is 3. We are also given that this larger triangle here is 4 plus 3, which is 7. These two sides appear to be congruent because it's got congruent, 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 congruent. So therefore, y would also equal 4. So if y is equal to 4, then that means all three sides of this larger triangle are 7. And if all three sides of this larger triangle are 7, then that makes it an equilateral triangle. So then you know all three angles of this triangle are equal to 60 degrees. 60, 60, 60. So x would equal 60 degrees. So again, if you take a look at this picture, we know that this piece here is congruent to this piece. So this is 4, so y is 4. And if this is equilateral, then this is 3 and 3, 3 and 4, 3 and 4. So you know all the sides are 7. And therefore, you know that this is an equilateral. And if it's equilateral, then all these angles are 60, 60, 60. Because if it's equilateral, then it's equiangular. Tomorrow in class, we're going to go over some of these things that we've learned about corresponding parts of congruent triangles being congruent, about equilateral and isosceles triangles, and next we're going to explore overlapping triangles. This is coming to the end of our chapter. See you tomorrow in class. Make sure you ask any questions that you may have.